This video will cover some topics useful about capacitors for the physics GRE. So capacitors are used to store and then release energy in electrical circuits. So they're commonly going to be parallel plate capacitors, which is why the symbol for a capacitor is as such. The voltage across a capacitor is equal to the charge it's storing divided by its capacitance, and this is also where the definition of capacitance comes from. The energy stored in a capacitor is 1/2 CV squared. So just if you want to remember this, it sort of looks like 1/2 MV squared, but don't draw too much meaning from that. Next up, if you actually want to know what the capacitance is, it's different for all sorts of systems, but the most common is a parallel plate capacitor, where the capacitance is kappa epsilon naught A over D. So kappa is the dielectric constant, epsilon naught's the vacuum permittivity of free space, A is the area of the plates, and D is the distance separating them. If you want to find the equivalent capacitance between two capacitors in parallel, that's equal to the sum of the individual capacitances. However, if you want to find the capacitance of two capacitors in series, the inverse of the equivalent capacitance is equal to the sum of the inverses of the capacitances of the original capacitors. So this is just the opposite of the rules for resistors. Finally, if you have a circuit with no current flowing through it or anything, and then you attach a battery, if that current has a capacitor, the voltage across it over time will vary as in this graph. So the most important thing to note is that over time the voltage will saturate at some level, which makes sense because over time the capacitor can only store so much charge across its plates, so the voltage has to approach some constant in the asymptotic limit. So I hope that this video was helpful, and if you have any comments, questions, or suggestions, please leave them below. Thank you.